The situation is different, though, when I add water to a chiral alkene. If I have a chiral and achiral reactants to create a new chirality center, the result will be I will form two diastereomers, right, in unequal proportions. And let's see why that is. The carbocation in this case is no longer symmetrical. I have two faces. Let's see if I can draw this appropriately. That methyl group is going to be coming up above the plane. Like that. The top face comes above the plane as well. But what's key here is this methyl group, right? It's not in the plane of the rest of the molecule. It's up on top of the plane. So that means the two faces are different. So whenever the two faces are different like that, this methyl group here, it turns out it'll make one lobe of that carbocation a little less accessible than the other. Okay? But we don't really need to worry about which of those two lobes will be more accessible. All we need to know is that we'll have an unequal mixture. This chirality center was not involved in the reaction, so it's going to be the same as what was in the original molecule. Okay? I have options then, as for the other one. I could attack from the top, I could attack from the bottom, but look at our products here. Okay? One is the same, right? 4R and 4R, those are the same. Okay? The other chirality center is different. So when part of the molecule is the same and part of the molecule is different, these are diastereomers. And one will be favored over the other. Now, sometimes you can take advantage of that in a certain reaction. If I had a very bulky nucleophile that we're adding here, a real large nucleophile, it would be very strongly affected by the chirality center next to it. Okay? That's the sort of thing that synthetic chemists take advantage of all the time in order to make new chirality centers that only have one configuration and you don't have too big of a mixture of products. Okay? So hopefully you could get a good amount of one and less of the other. It could be the fact where it's a minor change and you get 51 and 49 or 50.1 and 49.9 or something like that, but by necessity there has to be a different amount of one than the other. Now, if the other chirality center is way on the other side of the molecule, you probably won't be able to measure the difference, but there is a difference. You will have unequal amounts of the two, and that's clearly very important to understand. So let's think back. If I have just achiral reactants and I'm making a chirality center, I'm going to make an equal amount of R and S. I'll make a racemic mixture. If I have a chiral reactant and I'm making another chirality center in there, one will be favored over the other. We'll make diastereomers because the existing chirality center is unchanged in the reaction, okay? But the new chirality center could be R or S, but one will be favored over the other. They're diastereomers because part of the molecule is the same, part of the molecule is different. So they'll have different properties, and I'll actually be able to separate them. I can put those on a column and separate them with chromatography, like we did in lab, for instance. But one will, by necessity, be favored over the other. So that's all we have for this chapter. You do not need to worry about chirality at nitrogen and sulfur or prochirality. That just deals with something like this, where you can identify one face or the other of a compound. That's for prochirality, but we're not going to worry about that. So be able to assign R and S, be able to tell the difference between two compounds if they are stereoisomers, if they're enantiomers, diastereomers, if they're constitutional isomers, if they're completely the same, right? Be able to tell that. be able to identify meso compounds and draw a mirror plane inside of them, an internal symmetry plane in a meso compound. Be able to predict chirality of products of reactions. Achiral reactants will make racemic mixture, and I'll be indicating that quite a bit from here on out. If one of the reactants is chiral, you'll get an unequal mixture of two diastereomers. So that's it for us here.